Since we have more than one unit of measure, we need to be able to convert efficiently from one unit to the other. We will find as we go along that this is especially true of converting between radians and degrees. The grad isn't used very often in an introductory course on trigonometry, but the radian and the degree both play a large part in working with angles, so we need to be able to be efficient in converting between these two units. So, where do we start? Well, the one thing that we know about the circle and degrees is that one circle, and I can hear our minds all responding, equals 360 degrees. So that's a good place to start. Now if we only knew how many radian it took to equal a complete circle, we'd have at least the beginning of a relationship. Well, we know that an angle measured in radians, and I need to tell you that if a measurement of an angle is not marked, then it's considered to be radians in the trigonometric setting, because in the trigonometric setting, radian tends to be the dominant of the two units of measure. So a 1 radian angle, we know, cuts from the arc of the circle a piece that's 1 radius in length. So how many radii does it take to go around the circle? If we were to just start marking off radii, how many would it take us to get all the way around the circle? Suppose there's another one. And suppose there's another one. Any ideas? Hopefully, what I'm hearing through cyberspace, if you will, is some of us thinking about this little formula. The circumference of a circle is 2 times pi times the radius of the circle. Circumference means actually this arc that we call the circle itself. If we were to cut it and lay it out straight, this is its length, and that length is based on the radius. And in fact, it's telling us that it takes that many radii exactly to form one circle. Well, how many radii is that? Well, we know that this symbol, pi, is 3.14 if we round it off to 2 decimal places, but we also know that it's a non-ending, non-repeating decimal, the kinds of numbers that we call irrational. So 2 pi then would be approximately 6.28 radiuses. And since the number of radii in the arc is the number of radians that the angle is measuring, then we can say that 2 pi radians is equal to 360 degrees. Now, again, be very clear that this pi, this symbol, always represents the irrational number 3.1415 blah 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 blah. It's never equal to anything else in and of itself. The reason we can say 2 pi radians equals 360 is because with the radians we're talking about a number of radii. Now here it's easier to remember because we have that word there, but again it's quite common to see no word there at all because radians are considered to be an unlabeled measurement, because the definition of radian measure just says that the number of radians in the angle is the number of radii on the arc. So we consider it to be just a quantity of radiuses that takes us around the circle, as opposed to the rotation taking place in the angle itself, so to speak. So it's quite common to see 2 pi equals 360, and then to divide both sides by 2 and see that pi equals 180 degrees, and we begin to build this intuition into our brain that says pi is equal to 180. No, pi is still 3.14 or whatever, non-ending. So we have to keep in mind that this is representing a number of radiuses, radii, that it takes to land the same spot as 180 degrees of rotation will land us. So now we have a relationship that would allow us to go on to say that if we divide both sides here by pi, we would have 1 radian, and I'm going to put the abbreviation back again, is equal to 180 degrees over pi. By the same token, notice that if we had decided to figure out how many radians for 1 degree, we could have divided both sides by 180 and found that pi radians divided by 180 is equal to 1 degree. So the conversion factor, if you will, can be written either 180 degrees over pi or pi over 180 degrees. That's the relationship between those two units of measure. It depends on whether you want your outcome to be radians or degrees to determine which way to put your conversion factor.